Okay, so this is the notes for acids and bases. We come in contact with acids and bases every day. Many of them we have in our home, although we use them every day. Many compounds are not acids and bases. Some are salts, some are covalent compounds, so on and so forth. Okay, so here's the pH scale, and the pH scale runs from 0 to 14. The left side are the acids. So the smaller the number, the stronger the acids. So strong acids are going to be right here towards the end. Weak acids are going to be here, about 5 or 6. And then 7 is going to be neutral. And then the strongest bases are going to be down over here at 14, and a weak base would be right in here about, well, I guess right in here about 8 or 9. So you can see some common household items that are acidic and basic. So for now, just know the basics of the pH scale. We're going to do an entire lesson on where those come from and how they work. Okay, so there's basically 3 definitions of an acid and base. They're not different. They're all basically just highlighting a characteristic of what an acid and a base is. So let's start with the first one, Arrhenius. Need to write these down. A compound that increases H plus or H3O plus concentration. Need to know that H3O plus is called the hydronium ion, and that is on the back of your periodic table. So let's talk about that for just a second. Now, H plus and H3O plus, they're the same thing, and here's why. What happens is you have a hydrogen ion. Now, a hydrogen ion is just a proton, and here's why. Hydrogen has 1 electron and 1 proton in the middle. Okay, so H plus, well, if you get rid of this electron, you've now produced H plus, and H plus is simply just a proton. Now, where does this H3O plus come in? Well, if you have hydrogen, it's always going to be in water. So we're going to go hydrogen plus H2O. And what happens is water will actually grab one of those protons, or H plus hydrogen ions, and form H3O plus. So that's why H3O plus and H plus are the same thing. Arrhenius base is a compound that increases the OH negative or hydroxide ion concentration in solution. Okay, going with the definition of an acid, that an acid is one that increases H plus ion concentrations. Let's look at these two, HCl. Here's some H plus ions, or H3O plus. Here's just a couple for the HF, hydrofluoric acid. So, which one is the stronger acid? HCl. And the reason is simply because HCl. And the reason is simply because there are more hydrogen ions in solution. Okay, it dissociates more readily. So the stronger the acid, the more likely it is to increase the concentration of H plus ions in solution. How about this? Which one would be a stronger electrolyte? Well, HCl as well. Okay, that's the stronger electrolyte. And remember, electrolyte is one that conducts electricity in solution because it does have ions. Okay, how about this? Which one's the stronger base? Well, let's look back to our Arrhenius definition of a base. It's one that increases the concentration of OH negative ions in solution. So whichever one has the most OH negative ions in solution is the stronger base. So NaOH is the stronger base. Calcium hydroxide doesn't produce as many ions in solution. Note that NaOH only has one hydroxide per Na, but calcium hydroxide has two OHs per calcium. But, so it seems like at first glance, calcium hydroxide would produce more hydroxide ions. Well, it's great, but if you can't release them, like this, if you can't release them and they just stay together, it doesn't produce a basic solution. So again, it's all about which one ionizes or dissociates the most. That's the stronger acid and the stronger base. Okay, next definition, Bronsted-Lowry. Bronsted-Lowry definition said an acid is a proton donor, so it gives away a proton, or remember, an H plus ion. Bronsted-Lowry base is one that receives an H plus. Okay, so again, it's not different. It's still consistent with the last definition, but it adds more characteristics to what an acid and base are. So let's try this sample problem here. HCl plus H2O forms H3O plus and Cl negative. Well, let's look what happened there. What happened was HCl gave its H plus to H2O to form the hydronium ion, the Cl negative. So HCl must be the acid and H2O must be the base. Acid is one that gives away a proton, base is one that receives them. Let's try the next one. NH3 ammonia plus H2O. What happened in this one? In this case, water gave one of its H plus ions to ammonia to produce ammonium ion and hydroxide ion. So in this case, the water was the acid and the ammonium was the base. So basically, here's what water is. H2O is called amphoteric. Okay, that means it can act as either an acid or a base. So when would it act as an acid? Well, it would act as an acid in this instance when it's with a stronger base, such as ammonia. It would act as a base when it's with a strong acid, such as HCl. All right, how do you find something that's amphoteric? We're going to go with this definition. Basically, what I want you to know is water is amphoteric, as well as anything with a negative charge and a hydrogen to give away. Now, negative charge, how does that make it amphoteric and a hydrogen? Well, first of all, in order to be an acid, according to Bronsted-Lowry, it has to have a hydrogen to give away. All right, so this has something to do with the base. Being negative means that it will receive or be attracted to an H plus ion. So these down here are all amphoteric. It's got a hydrogen to give away, so it act like an acid. It's got a negative charge, so it could also receive a positive, because negative and positives are attracted. Same thing with the other two. Okay, so this would be for honors chem only, but a Lewis acid is one that accepts electron pairs. Lewis base is one that donates electron pairs. Okay, so that may seem really strange. Before we were talking about H plus ions of protons. Now we're talking about electrons. Okay. Now, at first glance, this may look totally different and unrelated to the previous two, but it actually is. Remember back to Arrhenius. Arrhenius acid is one that donates an H plus. If you donate a positive or get rid of a positive, you become more negative. Okay, I'll say that again. If you get rid of a positive, you become more negative. Okay? Well, there's two ways to become more negative. You can get rid of a positive, or you can receive negative particles, electrons. So it's consistent. Lewis base is one that receives an H plus, so it becomes more positive. Well, there's two ways you can become more positive here if you're a base. You can receive an H plus ion, a proton, or you can get rid of electrons to become more positive. So in the example we're looking at here, these two react to form this compound. Okay, so we've got, in this example, we've got Cl negative donating its electrons to AlCl3. Okay, and they're doing that by combining. If we donate electron pairs, that is a Lewis base. One that receives electron pairs, AlCl3, is a Lewis acid. Next couple definitions. Monoprotic acid. Okay, mono means one, protic refers to proton. So remember, an H plus is just a proton. So it's an acid with only one proton to give away. HNO3 only has one H plus or one proton to give away. This one right here, you need to know this. That is acetic acid. We'll learn its name later, but this is a monoprotic acid, and here's why. This H plus is the only one that can be given away. These H3 right here, those are covalently bonded to this carbon here. Okay? So this is actually a monoprotic acid. That's the only one like that you need to know. The rest of them, it's just however many hydrogens they have. So diprotic, 2 H plus ions. Okay? Triprotic, we've got 3 there. Okay, so last definition, binary acid. An acid with only 2 types of elements, and that's HCl and H2S. Now notice with the 2, HCl, that one's pretty easy to tell it's binary. It's got H plus and Cl negative. Okay, H2S, remember in the definition, only 2 types. So what we've got here is H2S has a hydrogen and a sulfur, so only 2 types. Okay, and then the second type is called an oxyacid, which I have here, my lovely handwriting. And that's an acid that contains oxygen and 2 other elements. One of them is going to be hydrogen for sure, because it has to be for an acid. And H2SO4, H3PO4, those are all oxyacids. All right, this will conclude the characteristics or definitions of an acid and a base.